Welcome to A-Level and AP Physics. In today's lesson, we will discuss question number 4 from May-June 2021, paper 2-1. This question is about waves, especially based on properties of waves and diffraction grating. These two concepts are very important because most of the time they will ask about these concepts in CIE exam. For part A, we need to state what is meant by wavelength for progressive wave. First of all, let's try to understand what is progressive wave. Progressive wave is also called traveling wave because these waves transfer energy in direction of wave. So that's the reason we call them progressive waves. And examples of progressive waves are transverse waves and longitudinal waves. Let's try to understand what is meant by wavelength with the example of transverse wave. So this is an example of transverse wave. Now, if we look at this transverse wave, we can take 2 points. Let's say we take this point and this point. Particles at these 2 points, they will always oscillate in phase. So simply we can say these 2 points on the wave, they are in phase, and the minimum distance between these 2 points is equal to 1 lambda, mean is equal to wavelength. We can also take any other 2 points which are in phase. Let's say if we take these 2 points, so the particles at these 2 points, they will always oscillate in phase. So the minimum distance between these 2 points, this is equal to 1 wavelength. We can also take any other 2 points. Let's say if we take this point on the wave and we take this point, so particles at these 2 points, they will also oscillate in phase. So the minimum distance between these 2 points is also equal to 1 lambda. This is how we can define wavelength. This is how you can write down your proper answer for this question. So let me highlight some points. When you define wavelength by saying the distance between two wavefronts, you must say minimum distance because this is the minimum distance between two wavefronts, or we can say between two crests. We can also say the minimum distance between two crests. We can also say the minimum distance between two troughs, or we can say between 2 points in phase on the wave. Another way to define wavelength is distance moved by wavefront during one cycle of source. It simply means that one cycle is completed by source. The distance traveled by the wave, that will be equal to 1 wavelength. So this is another way to define wavelength. For part D, it is given to us a light wave from a laser as a wavelength of 460 nanometers in vacuum. We need to calculate the period of the wave. First thing we need to understand is a light wave. So light waves are electromagnetic waves. So simply we can say light wave is electromagnetic wave. Now it is given to us, the medium is given. Medium is vacuum, and in vacuum or in air, the speed of electromagnetic waves, this is equal to speed of light, and the magnitude is equal to 3.0 times 10 to 8 meters per second. Means all electromagnetic waves, the speed is the same in vacuum, or we can say the speed is approximately same in air. So V is equal to 3.0 times 10 to 8 meters per second, and this is the speed of all electromagnetic waves in vacuum. Now we have speed and we have lambda. So we can simply say V is equal to lambda times F. F is the frequency, and the frequency is equal to 1 over T. So simply we can say V is equal to lambda over T, or simply you can say multiplied with 1 over T. And from here we can rearrange. So the T time period, this will be equal to lambda over V. Lambda is given to us, and this is equal to 460 nanometers. It simply means 10 to negative 9 divided by the speed of light. So 3 times 10 to 8. Now if we simply solve this, our final answer will be 1.5 times 10 to negative 15 seconds, and this is our final answer. So this is simply we can write down, this is our final answer. This question has 3 marks. The first mark is if you have written this expression, you will get first C mark. And the second C mark is if we have written, means we have plugged in these values. And the last mark is answer mark, and this is A1. So this is final answer mark. If your answer is right, you will get full marks. For part C, it is given to us the light from the laser is incident normally on a diffraction grating. We need to describe the diffraction of the light waves at the grating. So here is diffraction grating. So this one is diffraction grating. In this diffraction grating, you can see small holes, and these holes we call them slits. So these are slits. If you look at light waves, when they pass through this slit, these light waves, they spread out. And this spreading out of light waves as they pass through slits is called diffraction. So simply we need to say that waves spread out as they pass through the slit, and that is diffraction. Let me show you how you can write a proper answer for this question. So this is how you need to write down your answer. If you have mentioned in your answer waves spread out, you will get 1 mark, and this is B mark, means it has to be in your answer. And the second mark you will get if you have mentioned as they pass through the slits, so you will get second B mark. So this question has 2 marks. If you have mentioned waves spread out, you will get 1 mark. The second mark, if you have mentioned as they pass through the slits, you will get second mark. So total marks for this question are 2 marks. Geometric shadow. Maybe some of you are a little curious about that. What is meant by geometric shadow? Geometric shadow means that if these waves, they don't spread, you will not see the light here. So there will be shadow, means no light here. But in this case, when the light pass through the slit, it's spread out. So waves spread into geometric shadows. It means they will illuminate these regions, and these regions are the geometric shadows. For part D, it is given to us a diffraction grating is used with different wavelengths of visible light. The angle theta of the fourth order maximum is measured for each wavelength, as you can see in this figure 4.1. On y-axis, sine theta is plotted, and on x-axis, lambda is plotted. It is also given to us the gradient of this graph. This is equal to g. So from here, simply we can write down the g. This is equal to sine of theta divided by lambda. So this is the gradient. We need to determine an expression in terms of capital G for the distance d. So first you can start from here. For diffraction grating, we simply understand d sine of theta. This is equal to n lambda. We need to find d. So simply we can write down d is equal to n lambda over sine of theta. If we look at g, this is equal to sine theta over lambda. If we write down 1 over g, this will be equal to lambda over sine theta. Now we can simply replace lambda over sine theta with 1 over g. So this is 1 over g. In this question, it is given to us for fourth order maximum. Fourth order means 4, n is equal to 4, and this is divided by g. So d simply is equal to 4 over g, and this is our answer for this question. We can say d is equal to 4 over g. This question has 2 marks. The first mark you will get if you have written this equation. So you will get first mark, and this one is C1 mark. And the final mark is answer mark. So this is answer mark. For second part on figure 4.1, we need to sketch a graph to show the results that would be obtained for the second order maximum. So this is quite straightforward question. If we look at our previous result, we have found d is equal to n over capital G. For the fourth order, d was equal to 4 over capital G. Now from here, if we rearrange, we can find g. So g will be equal to 4 divided by d. Now question is asking us for second order. So we can write down g for the second order. This will be equal to 2 divided by d. But in this case, we are using the same diffraction grating, so it means d is the same. So d is the same, mean the slit separation is the same for the same diffraction grating. If this become half, now this become half if we compare with 4. So this decreases, this become half, so it means g also become half. Next thing we need to understand, g is equal to the change in y divided by the change in x. So if we draw the line from here to here, delta x is the same. Change in delta x is the same. So if g become half, it means delta y has to be half. So based on this, we can draw the line. So the best way to draw this one is, first we can look at this. So this is about 1, 2, 3, 4, 5 units. So we can take the half of that. So this is about 2.5 units here. And this is 10. So we can take the 5. So this is 1, 2, 3, 4, 5. So 5 units here. And then we simply need to connect. So in this case, delta y will be half, but delta x will be the same. So let me show you how you can draw a proper line. So this is how you need to draw the proper line. So this is how you can draw the proper line. You can see this is about 2.5 here. So this is about 2.5 units, and this is about 5 units. So you can see 1, 2, 3, 4, 5. So this is 5 units. So the gradient of this red line is half, and this question has 2 marks. So if you have drawn in a proper way, you will get 2 marks. So the first mark is for the straight line. If you have drawn the straight line from 400 nanometers to 700 nanometers, you will get 1 mark. If the gradient of this line is smaller than the gradient of previous line, you will get the second mark.